Okay, so I'll draw it for you. In this one here, you have air, and here we have water. And what is happening here is the diagram shows a large fish. So there's a big fish here. There's the fish. And the distance here down is 1.2 meters. A small boy is trying to catch the fish with a spear, aimed at the fish at an angle of 30 to the vertical through P. Not knowing what he sees is okay. Calculate the oar. So what's happening here is, here's the boy, he's trying to catch the fish. Now, he is aimed at, if I draw it in a different color, here's his eyes. He thinks the fish is here. And you know this, if you look at things in the water, they don't look like where you think they might be. And it's because the angle changes for the light. Because what's happening here is when the light for the fish, let me try that carefully, hits the water, what happens? It refracts. So this is why he thinks the fish is here, because it looks like it's straight to there. But what's happening is that the light from the fish is bending or refracts at this point. So he mistakenly thinks the fish is straight ahead, not realizing that it's further down because the light bent. Okay, now they give you angles, so I'll write them in. This angle here is 30 degrees. That is all you know. You can say the air has n equals 1 and the water is 1.33. Okay, what is the oar here for this question? The oar. And we're talking about from here to the man. What's the oar? What angle? What's the oar? Yeah, what is it? Give me the number. Very good. Oh, very good. It's 60 because we need to measure from the normal. So the oar is 60 degrees. Remember, we always measure from the normal, the perpendicular line. And which one here is the eye? Is it the small one or the big one? The big one here is the eye. Now, do you know eye? Oh, sorry. So, this is so stupid. I just said tomorrow. Good job. And then 1 minute later, this here is the eye. Thank you. No, that isn't 60. No. Now, do you know the eye? You don't. Do you know the oar?
Yeah.
Yes. Do you know the N1? Yes. Do you know the N2? So, can you get me the eye? You can. So, I'd like you to do that for me. I'll write the formula down and everything. Using
incidence, isn't it? Where the sight first goes into the pool.
No, forget about his sight. Just think about like the fish had a little laser on it and it's firing out to the man.
Oh.
Yeah. Sine I over sine R equals N2 over N1. Alright, I'll give you a moment. Get me the I, please.
40 plus 6.
We'll just let everyone get it, okay? Yeah. So you have one answer. So this is actually question 8B, part 1. Okay, what did you get? Yeah, so let me put the numbers in. So here it will be sine I over sine 30 equals N2, which is 1, isn't it? Over N1. Did I do that the right way around? Yeah? You got the same thing? Yeah? It is, it always seems confusing. It's V1 over V2 and N2 over N1. Okay, so you have
2.
sine I. What's wrong here, right?
No, it's not 40, it's 22 close. Was the other way around, so 22, not 40. Not 40.
There's a mistake here?
Oh, there's no mistake.
Okay, so sine I equals 1.0 multiplied sine 30 over 1.33. What's that?
22.25.
No, just give me the number first before the angle.
0.376.
Okay, and then the I,
22.
22 point.
It's 37. 0.08.
So 0.1 then. How did you end up getting 40 though? What was the mistake that you were making?
Angry multiplier.
Did you have it upside down?
So isn't that the sine 60?
Sine 60.
Sine
60.
Sine 30.
Huh?
Sine 60.
Oh, it's 60. 60.
So it's 40.60.
Thank you. So what's the decimal?
0.65.
65.
14.
Okay, and the R, 46
160.
degrees. Alright, so that was the right one. Okay, good. Okay, the next part is find the distance from the water to the buoy. So they would like you now to find this distance here. Can you see? From here to here. They would like to know what that distance is. How could you find that? Well, what distances do you know? There's only one distance you know. What's that? Yeah, the 1.2. You see here? You know this. Do you know this angle? Yes? So do you know this angle? Yes. And what's this angle? 90. So do you know this angle? So you know all three angles, true? And you know one of the sides. So therefore, can you get this side? Yes. And then can you get this side? Yes. So you know everything on this triangle. Now, if I look here, do I know this angle? Yes. Now, what else do I know about the buoy? Oh, you can't really see it in the picture, but the buoy, they take it as if he's standing like really close. So this distance here is really, really, really small. So you can make it 0. I'll try and draw that on the side by what I mean. So you know how I drew the boy standing like this? And he's looking down into the water? You can take the boy to be of no height. Okay, so if he's of no height, then where is he standing? It's like here.
So we just have to find this.
So basically, yes, just find this distance here for me. Here to here. Are you done already? What did you get?
1.03.
Yeah? Did anyone else get that? Can you check it? Yeah? Oh great, okay. So what rule did you use, Tanish? Just your basic sine cos tan?
Tangent.
Use tangent, okay.
Tangent of the opposite angle.
Tangent of,
Tangent of 90 minus 9.
yeah, okay, so that's this angle here, is it?
No, the other one.
This one here?
Yeah.
You said tan of this angle. Well, we could have used this one as well, actually.
Find it.
Yeah. Tan of 40.6 equals opposite, which is x, over adjacent, which is 1.2. So, can you type that in? 1.2 times tan 40.6. What's that, please?
Degrees are radians.
So it's 10 is 49.4 because 90 minus 40.6.
Huh? Are you sure? No, I'm using this angle now.
Oh.
Yeah. Yeah, so just type in that, please.
1.02.
1.02? What did you get, Tanish? When you did it? No, it's right. What did you get?
I got
Here, right, what did you get?
1.03.
1.03, which is the same as what you just got there, 1.028.
Yeah.
So the answer is 1.03. Tanish, meters. Tanish used this angle, I just used this angle. No difference. Same thing. Alright. The last part. Yes, always. The last part for this question is they want to know how much the boy misses by. So in other words, they want to know what this distance is here. Now, do we know this whole distance? We do, it's 1.2. So we need to work out this distance here. So maybe we could use something from maths class, like a sine or a cosine rule if you wanted. What information do we know? We now have this side and this side. We could use Pythagoras to get this side, couldn't we? If we knew this side and this angle, do we know this angle? No.
They ask for the height, the apparent height of what is looking at.
No, they didn't. They want to know the difference between these two here. You see from here to here, they want this distance. Can you see that? Annie, can you see what they're asking you for?
Yeah.
So can you try your best to get me the answer, and then I'll do it now in a minute. So I'd like to know the distance. Now, yes, Joshua?
No.
Oh yeah, so maybe if you want you could use a sine or cosine rule, because if you look at the triangle, it's not a nice triangle. But I feel like because they ask you for the x, that you should be able to use the x to help you get the answer. I think actually, let me see.
So can I
What's yeah,
know what's the
60.
answer?
because I'll do it in a minute. Which angle?
That angle by the green line.
Yeah, 60.
60.
All right. Yeah. Do we know the I? Look up, guys. Do you know the I? Yes. And now you see, as you said, this here is 60, isn't it? Which means that this whole angle here is 60. So then this angle here, 30. Now, do you know this side? Yes. Do you know this angle? Yes. So you could get this side here and then take it away from 1.2 to get the other piece here. So if I draw that at the side, we have this now. $30. 1.2 was it for x? No, 1.02 wasn't it? 0.3. So can you tell me what this here is? We should use, you have it? What is it? 0.59. Good, so then this here would just be 1.2 minus 0.595. That gives me the y then, because the total is 1.2. What's wrong, Mohammed?
What's wrong with that?
Are you focused?
Yes.
You don't look
I was
focused.
solving it with you. I was just solving it
Fine,
with you.
fine. What do we get here for y?
Are you sure?
0.0.
0.605.
That's the y. Yep. Did anyone else manage to get that?
I don't think we'll find one
For what? The y or the s?
for the S.
Oh, you didn't get this?
No.
Well, let's have a look. What do I need to use? Sine, cos, or tan? Tan.
Okay, that's right.
Okay.
Richard wants to find an answer.
What if you
Final answer is 0.605. Yeah?
what if you subtract the angle of incidence from 60 sine
Yes. Oh yes.
by 0.675.
0.675. So what did you do? You subtracted from the eye 60 to get that small angle.
Yes.
And then you said sine that small angle over y equals
Sine E.
sine the bottom angle
Yes.
over
Oh,
over what? You see, I think you're mixing up your two triangles here. Because you don't know. You're saying here, right, sine this angle over this side equals sine this angle over this side, which you don't actually know. Did you use x? Well, what number did you use?
okay.
You see the problem? Okay. Yeah? I'll just give you one more of these. I'll let you choose.
Just go to the right there.
To the right, yeah.
No, to the one.
Where?
Yeah, that's it.
You need to go for a minute? Okay. This question here had an A part as well. I'll just write it down here. The A part is they wanted the definition for n. So what's the definition of n? No, the other one. C over
V.
V. How can you put this in words?
Ratio.
Yeah, okay, good, yeah. The ratio of
The speed of light.
speed of light to speed in medium. How many marks do you think you get for that sentence? 1. Yes? Yes, come on in. Okay, I'll just mark this off the back. So what year was that, did I just say?
2007 A8.
A8. Okay. So we'll go back to the book now. So that's what it looks like in the exam. Oh, let me just give you a really quick one, just so I make sure that I think you can do this one here. So n is 1, n is 1.3. Here's the I, let's say it's 30 degrees. I would like you to calculate for me the OR, which I'll call X here. So just try to do this one really quick and then we'll move on.